Okay, this chapter 20 on electrochemistry. So there's a few things that we'll talk about here, and we'll eventually come back around to what we talked about in chapter 19 on spontaneous reactions and how it relates to electrochemistry. So one of the things we need to know about is what an oxidation reduction reaction is. Um, there's many types of reactions that you learned about in Chem 1, uh, synthesis reactions, decomposition reactions, um, single replacement, double replacement reactions. And this would be an example of a double replacement reaction here, where your positive and negative charges switch partners and you end up forming a precipitate. I'm sure you all covered that somewhere in Chem 1. So maybe you talked about redox reactions as well, which is just a short way of identifying an oxidation reduction reaction. And when there is an oxidation reduction reaction, then there's a change in the charges of the elements involved in the reactions. So here's an example of a very simple redox reaction that maybe at some point you've called a single replacement reaction, but it really has more to it than just that. So here's an example where I have zinc solid and it has a charge, as you know that um, that's the term you would use, the charge. Now we're going to talk about it as an oxidation number. And so what happens when zinc proceeds from reactant to the product side, where it ionizes and pairs up with the chloride, the charge on it becomes a positive 2. So what has happened is that the zinc has gone from a 0 charge to a positive 2 charge. It has undergone what we call oxidation. And then the hydrogen here has gone from a +1 to a 0 here. Because when hydrogen is in the molecular form, there's no charge to it. So what has happened to that hydrogen? The charge has become reduced. And so we call it reduction. So why isn't the chloride involved? Well, the chloride is a -1 here, and here in this molecule, it's also a -1. So nothing's happened to the charge. It's not involved in the redox reaction in the process of oxidation and reduction. So what has happened? The zinc solid, when it proceeds to the products, it loses 2 electrons. That's how the neutral solid becomes charged. And contrary to that, the hydrogen ions associated with the chlorine form the hydrogen molecule. And I would show 2 of those. I showed 2 of those because if I were to balance this traditionally, I would have that. So we call the process of losing electrons, loss of electrons is called oxidation. Gain of electrons is called reduction. And so then we show that reaction as an overall oxidation reduction reaction, and we only show the species that change. And so we leave out the chloride altogether because it never changes. So zinc solid plus 2 hydrogen ions plus 2 electrons goes to zinc positive plus a hydrogen ion. And you can't see it here because it got cut off, but it's plus 2 electrons on this side as well. So if I bring everything down that happens, that's what I would have. But in my final equation, I just eliminate the electrons. I don't include them. And you'll see that as I go into a bit more complicated examples. And then here I just show you another example where the synthesis of water, and I have hydrogen and oxygen forming two molecules of water, and I indicate how there's a loss of electrons with the hydrogen, how there's a gain of electrons with the oxygen, because here it's 0, and then it becomes -2. So in this example, the hydrogen, because it's losing electrons, is undergoing oxidation, and the oxygen, because it's gaining electrons, is undergoing reduction. Okay, so when in this example, I'm going to talk a little bit about naming each species. So if hydrogen undergoes oxidation, is called the reducing agent. And as oxygen undergoes reduction, it's called the oxidizing agent. And the reason they're named this way is because one cannot happen without the other. So in order for hydrogen to oxidize, when hydrogen oxidizes, it allows reduction to take place. That's why it's called the reducing agent. And when oxygen undergoes reduction, it allows oxidation to take place. I'm going to stop there.